Okay, physics students, mass and weight. Let's simply define them first. Now, you might remember from the beginning of the trimester, mass, it's simply how much matter is in an object, and matter is the stuff of the universe. Okay, if I take a cup and I have some toilet paper, and I take the toilet paper and I fill up the cup with toilet paper, you're going to have much more stuff in the object. See? Toilet paper, it's in the cup, okay? There's more stuff in this object than there was before. It's the quantity of matter in an object. It has this much mass on the Earth, and if I take it to the moon, now we're on the moon. If we're on the moon, it has exactly the same amount of matter. I haven't taken any stuff out of it. Now here's what we're adding. Mass is also the measure of the inertia or the sluggishness. It's a measure of the laziness of an object. The more mass an object has, the lazier it is. The more it is sluggish in response to any effort made to start it, stop it, or change its state of motion in any way. If I filled this cup with, say, lead instead of toilet paper, then it would have a lot more mass, and it would resist changes to its state of motion much more than if it were just empty. That's the new information about mass. Now, what's weight? Weight is the force upon an object due to gravity. So there's a certain force upon this object due to gravity, the gravity of Earth pulling the object down. Okay? If I take this particular object to the moon, it's going to weigh less because there's going to be less gravity on the moon. However, its mass stays the same. There's just as much matter in this object here on Earth as there is on the moon. Mass is a constant. Mass is the same no matter where you are in the universe, whereas weight changes depending upon the force of gravity. Here it is in sum. Take a moment to jot down these notes on mass and weight. Key point is that mass is the same no matter where you are. It's independent of gravity, whereas weight changes depending on your location in the universe. The greater inertia that you have, the greater the mass. The more mass, the more inertia. The more mass an object has, the lazier it is, the more it's difficult to get the object moving. Unit of measurement, kilogram, whereas weight is the force on an object due to gravity. They are related, however. Here's a question for you. If the mass of an object is halved, the weight of the object is what? Halved? Twice as much? Depends on the location? Or none of the above? Pause the video for a moment to select your answer. Correct answer is the weight of the object is halved. What's the relationship between the two? It is Newton's second law, as we are explaining throughout this series of lectures. Now, people tend to confuse mass and weight in everyday conversation and use the two words interchangeably, but in fact, mass is actually much more fundamental than weight. It's a different concept, though it is related. So, as I was saying, if you take an object on the Earth and bring it to the moon, it's going to weigh less on the moon. There's less gravity on the moon, but the mass of the object stays the same in both locations. Take this anvil here. When you take the anvil to the moon, you're not losing any matter. The amount of matter in the anvil remains the same. It has just as much matter on the moon as it does on the Earth, and it resists changes in its motion just as much on the moon as it does on the Earth. Yes, lift the anvil on the moon, it's going to be lighter than it would be on the Earth. But throw the anvil at somebody on the moon, and they're going to want to get out of its way just as much as they would want to get out of its way on the Earth, because it's going to be just as hard for them to stop the motion of that anvil flying through space on the moon as they would find it difficult to stop its motion on the Earth. It has just as much inertia. The inertia of the object, the mass of the object, does not change.